Hey everybody, welcome back. In this section, we're doing examples with derivatives and integrals with vector calculus. Let's just jump right into it. I want to find r of t if r prime of t is 2t for the x component, e to the t for the y component, and 2 pi times sine of pi times t for the z component. We're going to have an initial condition of r naught, or r at t equals 0, is 1, -1, and 1. This is called the initial value problem. So let's just jump into it. If r prime of t equals that, we're going to integrate it. So I integrate there, we'll integrate here. Integrating 2t gets me t squared. Integrating e to the t gets me e to the t. Sine goes to negative cosine, but we got this pi, we got to divide the pi out when we do the integration. We got -2 cosine pi of t in the k component. I did not have limits of integration on there, so I need to add a constant vector. So this is all kind of summarized over there. If I use the initial values, r of 0 equals 1, -1, and 1, I can figure out what C is. I wrote X, Y, Z here. I don't need to. I was just reminding you we're doing each component individually. I'm going to leave it as C. In later steps, we're evaluating at t equals 0. So t squared becomes 0 squared. E to the 0 is 1. And -2 cosine of 0. Cosine of 0 is 1, so this will be -2. I've got 0, 1, and -2 plus that constant vector has to equal my initial value. And we solve for that constant by subtracting. We subtract 0, 1, and -2 from the left side, and we get C equals 1, -2, 3. That's not what we wanted to have. We wanted R of t, so I'm going to take C and plug it back in. Gives me that. And I don't like listing it as two vectors, so I'm going to combine them into one vector. My x components combine, t squared plus 1. My y components, e to the t and -2 combine. And our z components, -2 cosine pi of t and 3 add up for the z component. Okay, next question. We want to evaluate the integral from 0 to 2 of 3t squared I hat minus 10t to the 4th j hat plus 12t cubed k hat with dt. You guys know how to do these integrals, so I suggest you pause it and see if you get the same answer. Calculate it out, see what you get. Assuming you did, we do the integral separately. So 3t squared becomes t cubed. -10t to the 4th becomes -2t to the 5th. And 12t cubed becomes 3t to the 4th. Don't forget your integration rules. We're evaluating from t equals 2 to t equals 0. So I do that here. 2 cubed is 8. T to the 5th, or 2 to the 5th is 32, times 2 is 64. And t to the 4th is 16, or 2 to the 4th is 16 times 3 is 48. Plugging in 0 just gives us the 0 vector. So our vector is 8, -64, and 48. Or you could write it with the 8 factored out. Okay, let's look at another example. We want to find where the tangent line for the curve r equals e to the 3t, 2 sine t, and -t minus 3 cosine t. Where the tangent line at r equals 0 is, where does that intersect the xy plane? Well, remember, we need r of 0 and we need r prime of 0 to make that line. So let's just figure out what it is. R of 0, I just plugged in 0 and found what it was. Let's calculate r prime of t first. Time derivative of e to the 3t is 3e to the 3t. Time derivative of 2 sine t is 2 cosine t. And the time derivative of -t minus 3 cosine t is -1 plus 3 sine t. Evaluating with t is 0, I get 3, 2, and -1. So my tangent line is r evaluated at t naught and t times r prime evaluated t naught. T naught was at t equals 0. So we have those two things right here. Our tangent line is this. It's 1, 0, -3 plus t times 3, 2, -1. I shouldn't have really used t because t is a normal vector. This is not normalized. So maybe I should just leave it as like r prime of t. R prime of t at that point. Combining into one vector, I've got 1 plus 3t, 2t, and -3 minus t. That wasn't the problem though. We wanted to find where this tangent line intersects the xy plane. Well, the xy plane occurs when z equals 0. So when does z equal 0? Let's calculate it. I plug in -3 minus t equals 0. I solve for t equals -3. I can find the other two components by plugging it in. Plugging in -3 into x is 1 plus 3 times -3 is -8. We do the same for y. I get -6. The z component was 0. That was our assumption. So that tangent line intersects the xy plane at -8, -6. That'll be it for this section. I've got one more section I want to do. Peace.